Hi everyone, this is to go over your lesson 3, or I'm sorry, your lesson 13, your homework from last night. So go ahead and make sure you have your paper out, make sure you have your work with you, and if you have any corrections, this is a great time to write them down. Remember, anything that you're learning now goes on your note card so that you can use it tomorrow. So let's start with what the question is asking. It starts with asking, at the supermarket, you can fill your own Honey Bear container. A customer buys 12 ounces of honey for $5.40. And then we're asked to find a couple of things. We need to know how much does the honey cost per ounce and how much can you buy per dollar. So you'll notice that over here, I've made my two columns, my honey and my cost. I started with my original amount, which was 12 ounces for $5.40. In order to find how much for $1, and that was the per dollar, I had to divide both of these by $5.40. In order to find out how much per ounce for 1 ounce, I had to divide both of these amounts by 12. When I did that, I found that 1 ounce of honey was 45 cents, or with $1, I could buy 2 and 2 ounces of honey. Now I went ahead and I put this into a table, and you'll notice that I have my X and Y coordinate points. But since it asked me to write two different equations that represent H for ounces and C for cost, I wrote this two ways. In this XY table, I chose to compare cost to honey. So the cost of 1 ounce, or the cost of $1, will give me 2 and 2 ounces of honey. Here I have 1 ounce of honey, and that will cost me 45 cents. So I have two different equations for the same relationship. My equations are always written y is equal to a constant times x. This is always my equation for proportional relationship. Now I'm just going to substitute. Here my x is the cost and my y is the honey. So h is my y-axis there. My honey is equal to 2 and 2/10 times the cost. For every 2 and 2/10 times $1, that's how much honey I get. That C takes the place of my X value. When C is 1, honey is 2 and 2/10. When C is 1, honey is 2 and 2/10. Here we just changed. Now we have 1 ounce of honey for 45 cents. Again, y is equal to k times x, and we're going to go ahead. Oh, I noticed I made a mistake there, and this should be my cost. Sorry about that. My cost, I'll put that in red since the rest of it's in red as well. The cost, oh, that doesn't want to work, which is my y value, is equal to 45 cents times whatever the honey is, or 1 ounce. 45 cents times 1 of the x, and we're calling that h, is equal to our honey. So these are my two equations. I'm going to pause right here and show you the graph. Okay, so here we have our graph set up. I want you to notice that on this first graph here, I made my graph and I labeled my axes. Here my x-axis is going to be my cost, my dollars. My y-axis is going to be my ounces. So I'm going to go ahead and plot the point that falls here, which is when my cost is $1, then my honey is a little more than 2 ounces. So if my cost is $1, I'm going to be right about there, 2 and 2 ounces. And so we'll go ahead and just draw a line right there. Here we have our x-axis is going to stand for our ounces, and our y-axis is going to stand for our money. So in this case, when our ounces is 1, we're going to have 4,500 or 45 cents. So we're going to go to 1 ounce, and it's going to be just under 50 cents, right about there. And then we'll go ahead and graph our line. It'll look like that. All right, so here we need to check to see if the 0.3 and 6/5 lies on the graph representing a proportional relationship. And we have to pick all of the points that would fall on there. Now, if these have the same proportional relationship as this point here, it means they all have to have the same constant proportionality. Well, what is the constant proportionality for this? So we have 3 to 6/5. Now we know that the constant of proportionality in an xy coordinate, our constant can be found by y divided by x, and that will give us our constant proportionality. So we're going to go ahead and we're going to take y and divide it by x. So y is 6/5, and we're going to divide that by 3. So 6/5 divided by 3 is the same as 6/5 times 3, which gives us 18/5. Sorry about that. I was interrupted. It's actually 6/5 times 1/3, which is 6/15, which is the same as 2/5. So our constant is 2/5, which means that each of these relationships has to have that same value. So let's go ahead and check and see if that happens. So here we're going to check each time to see, is y equal to 2/5 times x? And 2/5 was our constant in this relationship, our original relationship. So let's go ahead and test A. In A, x is 1, so 2/5 times 1. Y is 4/10. Are these equal to each other? Well, 4/10. 2/5 times 1 is 2/5. And 4/10 is the same as 2/5 is the same as 4/10. So 4/10 is the same as 4/10. And so that is correct. Let's try another one. So y is always going to be the constant 2/5, because that's what we found, times x. And the constant, remember, was from up there. So here we have 1½ is x, so 2/5. And since we're dealing with fractions here, it might make it easier for me to write 1½ as a fraction. Is equal to y, which is 6/10. So I just took this x and wrote it as a fraction 3/2. So I'm checking 6/10 is equal to 2 times 3 is 6, 5 times 2 is 10. Yes, those are equal to each other. C is not, D is not, and E is. And you can check your work by following the same process, taking your equation of a proportional relationship, substituting in the values, and checking to see if your equation is correct. All right, and here we have our problem about 4 cups of raisins for every 6 cups of peanuts. And it's asking us to write, again, 2 different equations. One where the constant proportionality is greater than 1, one where the constant proportionality is less than 1. So take a look at how I set up my tables. I still have my x, y table, but in this one I'm comparing raisins to peanuts, and in this one I'm comparing peanuts to raisins. And in each, I'm going to find my constant. So here we have raisins is 4, peanuts is 6. So my constant of proportionality is y over x, 6 over 4, and that gives me a constant of proportionality of 1 2/4 or 1 1/2. And that's my constant that is greater than 1. Now I'm going to compare peanuts, 6, to raisins, 4. My constant is y over x, so we're going to find 4 over 6. 4 over 6 is equivalent to 2/3, and that is my constant for that relationship, and that is less than 1. When you go ahead and draw this out, you're going to go ahead and have two different relationships. So let's take a look and see what those two different relationships would look like. In this relationship, we might be comparing raisins on our x-axis, and on our y-axis, we'll be comparing peanuts. And on this, we'll have a different relationship. Here we're comparing raisins to peanuts. And then we go back to that constant of proportionality, and we go ahead and graph those. When the constant of proportionality was less than 1, our equation was that peanuts was equal to 6/4 of x. And then we had that raisins was equal to 4/6 of peanuts. And we'll go ahead here and write the raisins there, right? Which means here, when raisins was 1, peanuts was 6/4. When raisins was 6/4, or when raisins are 6/4 when the peanuts are 1. So that's how we can go ahead and graph that relationship. So here you see what I have done. Here we have for 1 cup of raisins, there will be 1 1/2 cups of peanuts. Here for 1 cup of raisins, there will be 4/6 of a cup of peanuts. Here's your chance to be creative and come up with any ideas you have. And this goes back to what we had done earlier in the unit. For me, I went ahead and thought about something that I would probably like to have, but they usually cost money. So for me, this axis was going to represent money. And this axis here was going to represent pens because I love pens, especially certain types of pens. So my relationship is going to be pens versus the cost, and that's my title. So I've labeled my axes, I've graphed it with a title, I've come up with a situation. Now I'm going to put a point on it and tell you what that point means. I'm going to choose this point here, and this is telling me that for $10 buys 5 pens. You come up with your own situation.